Hi everyone, this is Mrs. Snowbeck. Today we will do Unit 4, Note 7. It's about a type of quadrilateral called kite. And a kite is actually a real shape in geometry. It's a quadrilateral with exactly two pairs of consecutive congruent sides. Remember, consecutive means right in a row. So see SP right here and SR right here. They had that tick mark on them. They're congruent. And then PQ and RQ, they are congruent. So when you have two sets of consecutive congruent sides, you're going to get a kite. A kite can also look like this. Maybe you've seen some actual kites in the sky flying that look like this, where these two are congruent and these two are congruent. That would be a concave kite versus this one over here. This one would be a convex kite. So kites have several properties that are a little different from other quadrilaterals. For instance, in a kite, only one pair of opposite angles are congruent. So you can see angle J and angle L. Those are the same sizes. They're congruent to each other. But K and M are not. So only one pair of opposite angles are congruent. So if J is 60 degrees, then L would also be 60 degrees. Another cool property about kites is their diagonals are, can you tell based on that symbol right there? These diagonals right here meet at 90 degrees, so they are perpendicular. Also, one pair of angles gets bisected. So this diagonal right here between A and C bisects angle A and angle C. So you can see that the diagonal between the non-congruent sides bisects that pair of angles. And only one diagonal gets bisected. So for instance, if you look at this segment from B to D, that one gets cut in half, but the other diagonal does not get cut in half, does not get bisected. Let's jump into number 1. Number 1, it says WXYZ is a kite. Find the measure of angle XYZ. If you trace from X to Y to Z, that's this angle down here. That's what we want to try to figure out. Now, in a kite, two angles are congruent. Can you remember or take a guess which two angles would be the same size? If you're guessing X and Z, you are correct. Z will also be 121 degrees. Now think back to last trimester when we learned about the sum of the interior angles in a quadrilateral. We did a little thing where we did n minus 2 times 180 to figure out what the sum of the interior angles was. Well, a kite has four sides. So if we do 4 minus 2 times 180, that's really 2 times 180, which is 360 degrees. So in every single quadrilateral, the angles should add up to 360. So now, if I could, start with 360 and minus out the angles that I know. I have a 121, another 121, and a 73. If I subtract those out, I believe I get 45 degrees left. So the angle of XYZ right in here must be 45 degrees. Number 2, FGHJ is a kite. Find the measure of angle GFJ. Let's trace that. G to F to J is this angle over here. So that's the one we want to solve for. Remember, in a kite, two angles are congruent. So which two? Take a guess. Which two would be the same size? If you're guessing F and H, you are correct. So I'm going to start the same way we started the last one, where we take 360 and we minus out the angles that we know. So we're going to minus out the 128 and the 72. And I think when we subtract those, if you go ahead and type it in your calculator, 360 minus 128 minus 72, I think there's going to be 160 left. Now, we have to split that between two angles. We have two angles left. So take 160, divide it by 2, and we get 80 degrees. So H must be 80 degrees and F must be 80 degrees. So the angle that we're looking for, angle GFJ over here, would be 80 degrees. Number 3. MNPQ is a kite. Find NP. All right, so they want us to find the distance from N to P over here. In a kite, one diagonal gets bisected. So it's this one right here. This and this will be the same size in a kite. So from M to R and from P to R. Notice M to R is 8, so P to R is also 8. Another thing that we know is these diagonals are perpendicular. So this and this meet at 90 degrees. I'm going to redraw this triangle. This is 6, this is 8, this is 90, and this is the side we want to find. So I'm just redrawing this triangle right here. Anybody see a way we can find x, or the distance of that last side from here to here? If you're thinking a squared plus b squared equals c squared, you're correct. We could use the Pythagorean theorem. So the 6 and the 8 are our a and b. So we can do 6 squared plus 8 squared, and I guess I'll use x because that's what's on my picture. So equals x squared. 6 squared is 36. 8 squared is 64. And it still equals x squared. So think about what's 36 plus 64. That is 100. And then we take the square root. And the square root of 100, you can go ahead and do it on your calculator, but it is 10. So guess what? That third side of the triangle is 10. So NP is 10. The distance from N to P. All right, last one, number 4. WXYZ is a kite. Find ZY. So ZY is down here. Ooh, notice we have an 8 and a 24. And that makes a little triangle there. And we know something about the diagonals as well. The diagonals in every kite are perpendicular. So the corner right up here would be a 90-degree corner. So think about your triangle that you see. Could you do the Pythagorean theorem again to find this missing side? Yeah, you sure could. So you could do 24 squared plus 8 squared equals, we'll just say c squared. So 24 squared, I think if you type that in, you'll get 576. 8 squared is 64. Now we have to add 576 plus 64. I think it's 640. And then we have to take the square root. So I'm going to get 25.298. So the reason I put 3 decimals there is because I wanted to show you how rounding works on this one. So I always kind of like 2 decimal places. See the 9 there? We want to look at the number that comes after the 9, and if it's a 5 or higher, we want to round it up. So think about 29. We're going to round that up to a 30. That's it. Now it's your turn, so please try Unit 4, Practice 7. Don't forget you're working on getting a calculator and refilling your pencils. And if your family's willing to send in a box of Kleenexes or tissues, that would be wonderful too. All right, good luck.